Hi everybody. Today my topic is cross product or the vector product of two vectors. Let's move ahead to see how to deal with this cross product. So the vector product or the cross product. Here I put a diagram. Here we can see there are two vectors A and B. Two vectors. Vectors means normally we know that it will be a segment of a line and having arrow. So it has that. So this is a vector, this is a B vector. And these two vectors are separated by an angle theta. And another important point, these two vectors, it lie in a plane. You can see here. This plane is shaded. Now, before starting this, I want to tell something about right-handed screw. Right-handed screw is one that when turned clockwise, so screw enters the material into which it is being screwed. And here it is on anti-clockwise. This screw moves upward. That's why I showed here upward direction, because if screw, this right-handed screw, if it turn from A to B, it means anti-clockwise. So screw moves up. And later we'll see if it is turned clockwise, because this one anti-clockwise. So later in other slide we will see if it is in clockwise, then screw moves down. This direction. Here right-handed screw, already I mentioned, turn from A towards B. So the screw turn from A towards B. So it will advance in the direction of small e cap. I put here symbol of unit vectors. So you can see here I put here arrow mark yellow color, this one, E top, there is a cap, so this is unit vector symbol, and from here to here this is unit vector, yellow color. So here I put clearly small e cap, it is a unit vector perpendicular to the plane containing A and B. So this unit vector is perpendicular to this plane. You can see that this plane, and here A and B, lying on it. That's why it says containing A and B. Now here, same diagram, and previous diagram, it has a small unit distance arrow that was unit vector. But here this vector, it is A cross B. This vector, A cross B vector. And vector product of two vectors A and B is a vector modulus of absolute A, absolute B, I mean magnitude of A, magnitude of B multiplied sine theta. This is the thing. Length A absolute, I mean A magnitude, B magnitude, sine theta. This is the length of this A cross B vectors. And it is in the direction of a small e cap here. In the direction of this. In previous figure, I have shown the unit vector, but here only I showed here A cross B vector. So vector product of two vectors A cross B equal to A magnitude, B magnitude, sine theta, but additionally I am putting here one unit vector, because then this is a vector product. That's why there will be unit vector here. Because here when I write A magnitude, B magnitude and sine theta, it is modulus, magnitude of the vector, magnitude. But when multiplied by this unit vector, then it is A cross B. Here diagram looks same, only one big difference is before this right-handed screw turned from previous slide, it was turned from A towards B, but now from B towards A. It means clockwise. So before, when it was anti-clockwise, screw gone up, our unit vector direction was up, and A cross B vector also was up, but now it is turned from B towards A. That is why it is written here, it will advance in the direction of E cap downward. That's why I put here downward. And this is small arrow unit distance, it is unit vector. And this red one, it is B cross A vector. So we got informations comparing the previous diagram and this diagram. It is here I wrote as A cross B is not equal to B cross A, because their directions are different. Before it was up, now it is down. So that is why it's written here A cross B equal to minus B cross A, because arrow this vector arrow was upward, and this screwed in this anti-clockwise direction. Now it is clockwise direction. So we have to write A cross B equal to minus B cross A. It is most important informations. So vector product of two vectors, when it moves down, it will be same thing, A magnitude, B magnitude, sine theta, and multiplied by unit vector E cap. But additional things here I added here, there will be minus sign. That's the difference. Now here A cross B. Before, in previous all the figures, there was an angle between A and B vector, that was theta. But here we are mentioning a specific way, it is 90 degree. It is not only theta, it is 90. So it means both these vectors are perpendicular to each others. So perpendicular to both A and B and has length equal to the area of the yellow blue shaded parallelogram. It is saying that this A cross B will be the area of this parallelogram. How it comes? So A cross B equal to A magnitude, B magnitude equal to sine theta, and this E cap, unit vector. So sine theta, this theta is 90 degrees. So sine 90, we know it is 1. So area of the parallelogram, it means this length and this length to be multiplied. So we get that area. That is why it is written here, because sine theta means it is 1. So remaining will be these two. So area of the parallelogram. And these two are the magnitudes. So if it is not 90, suppose if A and B are parallel, then angle between them will be 0, because now it is 90. When these two vectors will be parallel, then it will be 0. So consequently sine theta will be 0, because sine 0 means it is 0. So this A cross B, this whole value will be 0. So the vector is 0 vector. Here it is three-dimensional, and here whole discussion is about the unit vectors. We know that for 3D we have three unit vectors, I, j and k. Ij, it is on the plane, and k is perpendicular. So if we multiply for this one and you see the directions I and j, and direction is this way, ij. So if we multiply these two, what will happen? I is 1, j is 1, and this is 90 degree, because from here to here this is 90 degree angle, this I vector and j vector, 90. And there will be an unit vector. We know that previous slides we already saw that sine 90, then E cap. But here already we know this is unit vector, this is unit vector, so there will be another vector perpendicular k. So instead that E unit vector we are writing here k. So we got a new information that I cross j equal to k. Again for this one, here 90 degree between j and k. So if we multiply, I mean j cross k, then it will be 1 into 1 sine 90 and I will be perpendicular to this, because for this both, this is perpendicular. For j and k, I is perpendicular. For this one, k and I, j is perpendicular. Look at the diagram, then you will see, because I already showed here these directions means if it is this plane like z and x plane, and here k and I, k cross I, so 1 into 1 sine 90, then unit vector will be perpendicular, because previous all slide we discussed about unit vector, always it was perpendicular, either it was upward or downwards. So here same thing, but here as it is I and j, so upward unit vector is k. So I mean no, here is j, so result will be j. Here unit vector this I, so result will be I. Unit vector here it is k upward on this ij plane, so it will be k. So keep it in your mind, I cross j will be k, j cross k will be I, k cross I will be j. Now if we write in reverse way, instead I cross j, if we write j cross I, there will be only minus sign. In previous slide we have seen a cross b equal to minus b cross a. So here I cross j, it will be equal to minus j cross I, so it will be minus. So result is same, only one negative sign will come, because this information we need when we will do the example maths. So k, here it was j cross k, so if we write k cross j, it will be minus and I will be there. Again for this one, if we write before k cross I, if we write I cross k, so it will be here minus and result will be j minus. So we will find a vector product of two vectors which are in Cartesian form as this one. A equal to this, B equal to this. There are two vectors. So in that case, A cross B. So we have to do A and these to multiply both. Only it takes some time, but it is easy because we have to multiply this by this one, by this one, and by this one. So we have written accordingly. And with more simplification, we get like this. Now here one thing we have to look at, I cross I, it will be 0. J cross J, it will be 0. K cross K, it will be 0. So remaining all this, we get this. I cross j, I cross k, j cross I, all this we got. In the next slides, we will see what is the value of this. Already in previous slide, we discussed about I cross j. If it is j cross I, so it will be minus. Let's see. So here I have mentioned it very clearly that if it is I cross j, it is k. If it is j cross k, it is I. If it is k cross I, it is j. So all are positive. But when we are getting in reverse I cross k or j cross I or k cross j, value is same but only negative sign will be added. Here I put one diagram, always in anti-clockwise. Just you draw a circle and put 3 arrows in anti-clockwise directions. Then these direction, if you move like I multiply j, I mean I cross j, j cross k, k cross I, all are positive. When you will move anti, I mean this clockwise if you move, then it will be all minus. See here, j cross I, j cross I, you are moving this direction. Then k cross j, k cross j, you are moving also reverse direction. That's why it is minus. That's why I put here one circle. So in the previous equation in the last slide, so we are putting this value k minus j minus k I j minus I. Now we can write it in organized way. Organized way means only the I term will be here, j term will be here, and k term will be here. And this is done for other reasons. We have to write it as determinant form like this, because ijk, this ijk, and if we write a1, a2, a3, b1, b2, b3, then you see if I take I, then this we are not taking, this row we are not taking, we are taking only this 4, a2, b3, a3, b2. You see it is here. That is why we have to write like this, then it will be easy to calculate to find the determinant. So finding vector product of two vectors. Suppose we are given two vectors. Here I put diagram to compare like A and B. So A is this one and B is this one. It is on the same plane xy. So we know that A cross B is a vector. And it is perpendicular to both vector A and B. You can see A cross B, this is a vector and it is perpendicular on these two. That is why I put here 3D diagram. So this is the vector on the floor and this is perpendicular. So it is very clear, justified. It is perpendicular to both vector A and B. And in previous slide we have seen A cross B, this one, these two, we can write like this, ijk. So there will be 3, 2, minus 1. You see 3, 2, minus 1, a1, a2, a3. and b1, b2, b3, it will be here 5 minus 1 minus 1. Now we need to calculate this determinant. So it comes, now it's easy to calculate. So we calculated this and we found A cross B, it is also a vector. So we got minus 3i minus 2j minus 13k. So this is the vector, this one, perpendicular to these two vectors. Here we'll do one additional things. So first question is find the vector that is perpendicular to both of the vectors. It is same as the previous slide what we explained, that one, but additional things is hence find a unit vector that is perpendicular to both A and B. So same diagram I put. So matrix, I have to take this value a1, a2, a3, b1, b2, b3 from these two vectors. Already I have taken. Now A cross B, I got this. So it is this one, minus 11i plus 9j minus k. So this is first part. Find the vector that is perpendicular to both of the vectors, because A cross B, you can see here it is perpendicular, but here also I put here one small yellow arrows. It is unit length, so it is unit vector. That diagram unit vector I have to find. So what I will do, so I have taken the previous slide last I got at an end, A cross B equal to this, minus 11i plus 9j minus k. So here I have to find the magnitude of A cross B. That's what I did. It's easy procedure. So A cross B, this magnitude is square root of 203. So unit vectors will be, as you know, A cross B divided by magnitude of A cross B. So A cross B already we got this, and magnitude we have this. So this is the result of unit vector. Our second questions, find a unit vector that is perpendicular to both A and B. So this is the result. With more simplification, we put like this. So this is the answer. And that's all for today. Thanks for watching.